So this is a problem taken from 2.2. Find the range, rank, null space, and nullity of the following matrix. And this is a 3 by 3 matrix. Okay, so we are going to do it using Gaussian elimination. So the first thing we do is to calculate the null space. And to calculate the null space, we need to solve the system a times x equals 0. Okay, so we write the augmented matrix for this system. And the independent coefficients are all zeros. And we start doing Gaussian elimination. So the first pivot of the first row is this. So this means that these two things have to be 0. So we do Gaussian steps. So the first Gaussian step, we want a 0 here. Therefore, we are going to do row 2, where we want the 0 to appear, minus the ratio between the thing we want to be 0 and the pivot we are using to create that 0. So 2 divided by 1 times row 1, and this goes into row 2. Okay, so what is the result? So 2 minus twice the row 1. So 2 minus 2 is 0. Minus 4 minus twice the row 1. So let's not get confused. This is minus 4 minus 2 times minus 2. So this is minus 4 plus 4 equals 0. Then 2 minus 2 times the row 1. That's 2 plus 2. That will be 4. And then 0 plus 0 will be 0. Okay? Next, we want a 0 to appear here. So therefore, we start with row 3. And we subtract the ratio of two numbers. Which two numbers? The number that we want to make 0 and the pivot that we are using to create this 0. So minus 1 divided by 1 times row 1, and the result we put it into row 3. So this means basically that we are doing row 3 plus row 1. Okay. So therefore, minus 1 plus 1 is 0, 2 minus 2 is 0, 1 minus 1 is 0, and 0 minus 0 is 0. And like that, we have achieved our row echelon form, where the first row has a pivot, the second row has a pivot, and the third row doesn't have a pivot. All the pivots are to the right of the pivots above, so we are in row echelon form, and therefore we can start solving. So remember, each of the columns represents one variable. What do I choose, x1, x2, x3, or x, y, z? What do you prefer? It doesn't matter. Let's do x1, x2, x3. So this column represents x1, this column represents x2, and this column represents x3. So which is this column doesn't have a pivot, therefore x2 is a free variable. Okay? So we do x2 equals lambda. No pivot, free variable. So x2 equals lambda. And now we do inverse substitution. So from row 3, 0 equals 0. There's nothing to do there. From row 2, we have that 4x3 equals 0. Therefore, x3 equals 0. And from row 1, we have that x1 minus 2x2, which is minus 2 lambda, because x2 is equal to lambda, minus 1x3, which is 0, equals 0. Therefore, x1 equals 2 lambda. And just like that, we have found the solution to our system. Let's write it in a nicer parametric way. So we can write the vector x, which is equal to x1, x2, and x3 is equal to 2 lambda, lambda, and 0, yes, which we can write as lambda times 2, 1, 0. And this is indeed our null space. Okay, so we could say that the null space of A is this line, which we can either write as lambda times the vector, or we can say it's the span of this single vector, 2, 1, 0. Yeah. So that's the null space. What is the nullity? It's equal to the dimension of the null space. Since it's a line, it has 1 degree of freedom. the dimension is 1. It is also equal to the number of columns that didn't have a pivot, which is 1. Perfect. Next, the range. So the range of A is equal to the span of the columns of A that had a pivot in row echelon form. So this is really simple. So row echelon form is this matrix U. Let me copy it here. Okay, this was the matrix in row echelon form. And the original matrix, I'm going to copy it here. So we have the original matrix and the matrix in row echelon form. So what are the columns that had a pivot? So the two pivots were these ones. So the columns that have a pivot are these two. They are associated with x1 and x3. Therefore, we know that these two columns are linearly independent. And actually, we know that this column here is a linear combination of the other two columns. Okay? So, knowing that, we know that the span is equal to the columns. We know that the range of A is equal to the span of the columns that are linearly independent of one another, which is this column and this column here. Okay, and that's the simplest way of finding the range. What is the rank of A? The rank of A is equal to the dimension of the range of A. Since we have the span of two vectors that are linearly independent, this is equal to 2. And indeed, 2 plus 1, rank plus nullity, equals 3, which is the size of the input vectors x. Okay, so the theorem of dimensions is fulfilled. Also, the rank is equal to the number of columns that have a pivot. Okay, so that's it. That's the very fast and easy way to calculate the null space and the range of any matrix using Gaussian elimination. Thank you very much.